few more things to cover from Chapter 4. The idea of nested loops, and something you can use loops for, input validation. That might be the first thing. That might be of interest to hit first before you start to get bored. I'm kidding. I know that these are dreadfully exciting. So let's go ahead and make our new lecture. I like to remove the project specifier so that we just get the main class. All right, so we're going to do input validation. A little bit of it. Yeah, there's multiple things you could do. Like you could insist that the user enter a number between 1 and 100, right? Those are the only valid numbers. If they type in something less than 1 or they typed in something greater than 100, it's not a valid choice. Or say that you were doing a numerical menu and you had 9 options, and if they typed in higher than 9, it's a problem. Or you're asking for a positive number, you don't want to allow any number below 0. Let's do that one, right? So why don't we declare a variable to hold what we're asking for? Good enough, right? And then let's write a loop. While d is less than 0, see, I initialized it to an invalid value so that it would enter the loop. So while d is less than 0, let's ask them for it. System.out.println, just print. Enter a value greater than 0. Right? Just like that. And of course we need our scanner. My typing's off today. Forgive me. Why is that a problem? Okay, good. It corrected itself. There we go. Add the import. I'm going to come up here and change that to just add java.util.asterisk. In case there's anything else out of java.util I need, it'll bring it in. All right, so now we have our scanner. Let's get our value. D is equal to sc.next. Double, right? Now, let's check. Is it okay? If it's not okay, we need to let them know that there's a problem. If d is still less than or equal to 0, there's a problem. Or we could do while d is greater than 0 break, but I'm going to do it this way this time. So if d is less than or equal to 0, then we're going to print system.out.println value must be greater than 0. Now this is actually just checking to see, right? Why don't we make it greater than or equal to 0? No, we want it greater than 0. So I need to modify this, right? If the value is less than 0, same criteria here. Okay, so if there's a problem, we report. Else, it's going to exit the loop, right? By the time we get to here, we know we have a value that's greater than 0, right? Because it wouldn't have left the loop if it was not. That's one way you can code that. Another, and this is a particular way, I have a particular fondness for doing this, is using what's known as a while true loop. Let's just ask for another number that has to be between, 1 and 10. But I'm just going to code it like this, while true. That's an infinite loop. It will loop infinitely until it hits a break statement. So we will be adding a break statement at a certain point. So let's tell them we need a number between, I don't remember what I said, 1 and 10. System.out.print parentheses. Please enter a number between 1 and 10. Right. And let's read it in. D is equal to sc.next double. There we go. And if it's great, if it's okay, break out of the loop, right? So if D really is greater than 1 and less than 10, it's good to go, right? So D greater than equal to 1, ampersand, ampersand, D less than equal to 10. then break. We're good to go. Not Barack, break. Else we have a problem and we need to print out our error message. I'm just going to copy that print statement, paste it in here, right? Value must be greater than 0. No, not this time. Value must be between 1 and 10. And I hope they understand that we mean inclusive, right? You know, we could rewrite it. Value must be not less than 1 or greater than 10, whatever. Hopefully they mean that. I guess I could add the word inclusive, right? Not many non-math or non-computer science students would know what inclusive meant, but we'll just run with that. Okay, so that's another way of doing data validation. This is a while true with a break. As soon as they give us a good piece of data, we break. I just kind of happen to like the logic for that, but I've had students tell me that they kind of like this logic. If you like that one, and that's the textbook way of doing these things. Actually, the textbook way of doing these things is to ask for the value right off the bat. It's called a priming read. Something like this. System.out.printf. Enter an even number. Let's get a new variable, an integer, right? So sc.next int. And while, how do you check to see if a number is even? You modulus it by 2, and if the result is 0, you know it's even. So while I modulus 2 not equal to 0, or you could just say equal to 1, right? That would work either way. Odd number, just to let people know why. Then you print out the error message and ask for it again. So print out an error message. I love using copy and paste. That was not an even number. All right, I don't know why I did printf here. I'm just gonna make that print. Sorry about that. I'm just gonna be print ln. And then ask it again, right? Print an even number, enter an even number, and then get the value of I again. Right? There, that's the textbook way of input validation. It's probably what the slide shows if we go back to the PowerPoint. Why does that work? Because you ask for a value, and if it's correct, it skips entering the while loop. I just kind of like doing it like this, where you initialize it to an incorrect value, and you go in here and you have an if statement that prints the error message out. Why do I like that? Because I don't like having duplicate code. I don't like asking and using the next command right there and right there, right? That's two places that, you know, if I needed to make a typo correction or whatever, I would have to correct it in both places. That's the most trivial reason for avoiding duplicate code, but it is a, you know, something to consider. So that's 3 different ways of doing pretty much the same input validation idea, right? Initializing your value to an incorrect value, and then having a while loop, and after they type in their data, you check, and if it's still incorrect, then you tell them. Or you use a while true with a break. This is my favorite. The logic looks least convoluted to me. I understand that one. That's the way I go for it. If it clicks with you, great. If it doesn't, blow it off. You'll probably see me use other examples of that, though. All right, and here's the other way. This is known as the priming read. You're priming the pump. You're getting an initial value before you hit the while loop. And then the while loop only gets entered if the value is wrong. And if it is, we warn them and make them type it in again. Okay. What if they type in something that would crash the program? For example, they type in something with letters or a floating point number to where it wanted an int. So here we go. Now this one's a double, so who cares? Okay. Please enter another number between 1 and 10. Okay, great. I'm not checking the error handling. I'm confident it works. I mean, I guess I could, right? -1? No, it must be between 1 and 10. Fine, 10. Enter an even number. Okay, 3, that's not even. Enter an even number. Now I'm going to type in something that's erroneous, like 3.5. And it crashed. It generated an exception. How can you avoid that? Well, if you're using, there's 2 ways of handling that. One is you could read it in as a string, and you could test the string to see if it is an integer. But we have the scanner class, and the scanner can rule out integers. Excuse me, it can rule out non-integer input. The other thing you could do is read it in as a double and just convert it to an int. But even then it wouldn't work properly if they typed in like letters, right? Boom, it's blown up. So we don't like that. Here's what we're going to do. We're going to use a scanner function called hasNextInt. That's the function we're going to use. We're asking the scanner if what the user typed in is equal to an integer. If it's not, we can get rid of it with just a call to sc.next. That will just discard that value, right? Or actually, you know, it's reading in the next string, and we could store the results in a string, right? So anyways, let's take advantage of those functions. Excuse me, methods. Let's tell them to enter an int, and then let's verify that it's an integer before we actually try to read it in to prevent crashes. So system.out.print, enter a whole number or else, end quote, parentheses, right? I'm going to make this a while true loop. Okay, while true, ask them for it, but we're going to check if the scanner dot has next int. If the next thing coming into the scanner is an integer, it's great. Let's read it in. I equals sc dot next int. Right. Good going, and then we can break out of the loop because woohoo, we got something good. Else, we need to eliminate what's in our input. And we don't really need to even put it inside an else block, right? Because if we get to this point, it is effectively the else because we broke out of the loop otherwise. So, sc.next, eliminate the last thing typed, right? And it will keep repeating. Somewhere I've lost one of my closing braces, so I just added it back. What's your problem? The assigned value is never used. Okay, fine, but we're going to use it later. That one always gets me. Let's run it. Enter a value greater than 0, 1. Enter a value between 1 and 10, 2. Enter an even number, 2. Enter a whole number or else. I type in some garbage. It's wrong, right? Enter a whole number or else. You know, I type in something with a decimal point. It's wrong. Enter a whole number or else. 5. All right, maybe we ought to print an error message saying what was wrong and why they're being asked for that value. So before or after we say sc.next, we just need to let them know system.out.println invalid input. Right? Good enough. This is pretty clear, so I'm not going to even worry about whether they understand why it's invalid input or not. We've told them pretty clearly, and so when it loops, it'll let them know. So now we've used loops for input validation. We could nest these things. What do I mean by that? We could demand an even number, and we could make sure that we don't crash based on what they type. Now we're combining the ideas. So what's a nested loop? A nested loop is just a loop inside of a loop. Let's make a loop inside of a loop before we make it a little bit more complex with, you know, doing input validation. For loops are easy to demonstrate nested loops with. So I'm going to make something that starts with 0, I is equal to 0, keeps going up to 10, I plus plus. Why not start at 1 instead? That's more fun, right? What are you complaining about? I is already defined. That's true. Okay. X. And then for integer y is equal to 1, y is less than or equal to 10, y plus plus, right? This is a loop inside of a loop. And then let's just print out x and y, right? System.out.print L in parentheses x plus a space plus a y, right? About the simplest example, probably the easiest to understand. The inner loop has to run and complete before the outer loop can exit. Excuse me, before this has to run completely before the next time the outer loop iterates. We could even put system.out.println after nested loop, and we're going to add the same message here before nested loop, right? Just so that the output is really, really, really clear. Let's say it before the inner loop, right? And then after the inner loop. And we could put a print statement up here that says before the outer loop, right? And then after the outer loop. So we run it, and we sure do have a lot of input going on. Alrighty. Pass this way. 2, 2, 2, 2. All right, and here it ran our nested loop, right? I'm gonna have to scroll way up to see where it started. I should have made the numbers like 3 rather than 10. But before the outer loop, can I drag this so that it's visible at the same time as the other one? All right, yeah. So before the outer loop, it comes into the loop. Before the inner loop, and then the inner loop has to count all the way up until it concludes, which it does, right? And that's why it prints 1, 1 all the way up to 110, because y, the second value, is being iterated all the way to 10. We exit the inner loop right here, print that out. It comes back up. X has been incremented to 2, and so before the inner loop, and now it prints 2, 1 through 10. After the inner loop, X gets incremented to 3. There we go, it's now 3. Enter the inner loop. It does all that 10 times. It exits the inner loop, prints out these 10 numbers, prints them out, and so on. I hope that's real clear. This is a nested loop example. All right, let's do something a little bit more practical than just printing out the numbers, 1 through 10. How many numbers did it print out total? How many times does this statement execute? Well, let's execute it 100 times, right? Because the outer loop is 10, the inner loop is 10, and so it repeats this 10 right here 10 times. So 10 times 10 is 100 iterations. If we scrolled up and down, we'd see 100 pairs of numbers printed out, right? All the way from 1, 1 up to 10, 10. So, using nested loop for input validation, we want a number between 1 and 10. That's really what we want. We want an integer between 1 and 10, and we're going to an int. We're going to try to make it crash proof. So what are we going to do? We're going to have the outer loop do the validation to see if it's between 1 and 10, and the inner loop is going to make sure that it is an integer using hasNext. So, while true, told you I like while true, and you can express this in one of the other ways as well, right? With a priming read or whatever. Let's tell them what we want. System.out.println, enter a whole, enter 1, 2, or 3, right? Those are going to be our choices, 1, 2, or 3. It has to be 1, 2, or 3, or we're not going to allow it. Let's just change that to print. Put a colon there, we'll let them know where to type. Why don't we declare a new variable for this just for fun? Okay, so num is equal to, but we're not going to do sc.nextInt because that could crash. So instead we have to have our hasNextInt logic. I almost hate to do it this way because now I'm going to have a priming read where I did not have a priming read up here. I guess I'm going to have two nested while true loops. Not totally thrilled with that, but we're going to go for it. All right. I should not have deleted that message without copying it. Okay, so while true, there we go, right? While true, we want a number between 1 and 3. I better fix my comment up there, right? And make sure it is a valid int. That's what we're going to do there inside the inner loop. Let's check, see if it's good. If parentheses sc.hasNextInt equals false, if it's not true, then it's bad. So let's say if not hasNextInt, then let's tell them what they did wrong. Or I guess the way we did it last time was we did if it was true. Yeah, if it was true, then we read it in and we broke. Let's do that. So if hasNextInt, if we're good, if we have an integer, let's read it in. Num is equal to sc.nextInt, parentheses, and then break. Else we have a problem, and we need to warn them about it. System.out.println, that wasn't a whole number. Right? And don't break, right? It's bad news. We didn't get it right. And then we need to clear the input buffer. So sc.next, eliminate the incorrect data. And let's add a comment here that says, okay, this is good data. Now the right thing to do is to put this inside a method so that you can just call it when you want, right? You can say get int, and it does all that looping for you. But we're not going to turn this into a method. We're just going to roll with it. Okay, so by the time we get here, by now, we have a valid int. See if it is between 1 and 3, or if it is 1, 2, or 3, right? We need an if statement, right? If num, I could do equals 1 or equals 2 or num equals 3, but let's just do if num is greater than or equal to 1 and num is less than or equal to 3, because those are our valid choices, right? If that's true, we can break, right? Else we need to tell them. All right, it doesn't seem to realize that the only way we could get here is if we have a valid value for num. And so it says num might not have been initialized. That's not true. The only way we can get here is if num has been initialized, excuse me, if this worked. But the compiler doesn't know that, so I'm going to go ahead and give a starting value to num, even though that value is never used. Okay. So we come down here. If it's a good number, we break. If it's not a good number, we tell them that. We don't even need those braces since there's only one line there. Did this actually have to be put inside of an else? I made a mistake. That's why it was yelling at me. My mistake, and I apologize for that, is that I needed to actually be after the while loop. I forgot that it wasn't after the while loop. Okay, so this had to line up with this. Now, by now, we do have a valid int. Maybe that was the source of that problem. If that's If it's a valid number, great, break. Otherwise, tell them it was not. System.out.println number invalid input. Let's just tell them that was wrong. Right. Or must be between 1 and 3. Must be 1, 2, or 3. Right. That's more user friendly. And so, somewhere down here, this is the end of the other while loop. We now have a value of 1, 2, or 3. We could do something with it, right? Now, if I was going to try to shrink this code so it might fit on one page, in one screen full, I don't know if I can really do that, but it's not strictly necessary to have an else. And I mentioned this higher up, but if you have a break here, there's no way that it's going to get to this stuff. So you don't necessarily need the else. So I'm going to do a little bit of trimming here. Just eliminate a few lines. And I'm going to do the same thing down here. Let's add a comment. We have good data here. And let's add a comment. We have good data here. Don't need an else statement, right? For reasons I've explained, because if you break out of it, then it's not going to possibly get there. Okay, I didn't quite get it all on one screen. Close, right? While true, we want a number between 1 and 3. While true, make sure it's a valid int. That's what the inner loop does, is it makes sure it's a valid int. Make sure it doesn't crash. So inside the inner loop, print into the number. If it's a valid integer, if has next int, then read it in and break. And that exits the inner loop. Else we complain, we ignore that piece of data and it loops and it asks for the number again. Okay, so once we've exited the inner loop, I don't want to add too many comments. So end inner loop. How about that? And then by now we have a valid int. See if it's a 1, 2, or 3. Same business. If it's valid data, then break. Else, tell them what's wrong, and it'll come back up here, and it will reiterate again, right? It'll go through this again. Same business. Ask for a new number. Make sure it's an integer. Come down here and compare. I hope that makes sense. Really hope that makes sense. Yeah. I should make it a requirement that you always loop to ask for valid data. I don't think I'm going to make that a requirement, but I should, right? Because if you're writing professional software, you're not going to want the users to be able to crash it. Now there are other ways of correcting for bad input. And one method is known as exception handling. I'm going to give you a demonstration of that, and then we're done with the chapter. And this is not in the chapter, it's considerably later. One last time, we're going to ask for a number that's either 5 or 6, right? That's the only thing that it can be. And if they choose something else, if they type in something invalid, oh, heck, let's not make it too hard. Let's just ask for an int and loop continuing until they type in an integer. But let's not do has next int. Instead, let's capture the error once it occurs. Do you remember that? It crashed when we typed in a non-integer. Well, we can handle that crash. So let's create a new variable. I don't know what we're going to call it. Let's just call it age, right? Enter age. Who cares? System dot. What we're going to do here is we're going to do try. New keyword, try. And then underneath the try, we're going to add a catch. This is what happens if there's a mistake. We catch the problem. But if there is a mistake, we're going to need to loop. So we know that we need a while loop to handle this. So, am I going to use a while true? Yeah, probably. Okay. So, until the break, keep repeating infinitely. I want you to try this. Try this out, gang. System.out.print, parentheses, enter age. Whole number. Just tell them. All right, better be a whole number. And let's try to get it in. Age is equal to sc.nextInt. This is the part that can crash. Might crash. Technically, it's called throwing an exception. Might throw exception. That's what the catch is down here. If it throws an exception, then we need to handle it. But if it doesn't throw an exception, great, it worked. System.out.println, congrats, you typed an age. A little bit sarcastic there. And we can break. Now, what if there's a problem? Well, I've forgotten the exact error that gets thrown. So forgive me for having to undo a couple of things to get to the point where I can figure out the exact error that is thrown without looking it up. And to get that to work, I'm going to have to comment that out. You don't need to do this if you're typing along, right? Just be patient, let me figure it out. I'm going to run it, type in a bad number, and see the exception, right? Right off the bat, we can find that out, right? Enter value, and I'm going to type in something with a decimal point, or, you know, that comma would have crashed it too. Yeah, right? Okay, and it blows up. What is the exception? Java.util.input mismatch exception. This is the important part. Input mismatch exception. That is the exception that is thrown. So, I'm going to go back and make this work. Try this stuff. If it fails, an exception will be generated. The type of exception is input mismatch exception. You can see why I copied and pasted, right? If there's a problem, we need to tell them that it was not a whole number. System.out.println. Input was not a whole number, or a valid, number, something like that. Just let them know what was wrong. I think our output now can go back down here on the bottom so as to let the code exist horizontally clean. Okay. If you look, this is shorter than using the hasNext method, right? I can't argue for one over the other, except this is shorter and perhaps cleaner looking. And when you're writing things and you're trying to, you usually want to err on the side of making your code elegant looking and clean looking, because it's easier to maintain, easier to understand what it's doing. If somebody else needs to modify it, they can come in and understand it more quickly, right? So we were able to do this. Now, honestly, the reason this example got more complicated is because we also were validating our input to make sure that it was between 1 and 3. We did not do that here. If we were going to do that here, it would definitely need to be a nested loop. I suppose we could do that here. Oh, you already get the idea, right? I would just have to have another while loop, and then we would need to test it. And if it's valid data, right, if valid, and then break, right? That's how we would handle that. All right, now I've got a whole bunch of nested breaks, down here or something. This is the end of the while. This is the end of main, and this is the end of the class. If you were typing along, I hope that you managed to line up all the braces correctly. You can always go and look in the notes, compare what you're typing to the notes. And I always recommend at least loading up the code, right, if it didn't seem to make total sense while you were watching the lecture, and then looking at it, right? Okay, so what's our homework going to be for this? Ask for a temperature in Kelvin. The big deal is that a Kelvin temperature cannot be negative. Kelvin just goes down to absolute 0. You don't care what Kelvin is. I don't care what Kelvin is. It's just a reason for asking this. Okay. Then ask for the user's age. If they type less than 0, can't be 0 years old, or more than 200, right? Then tell them it's an invalid age. Do not allow the loop to exit until they have a valid age. And then lastly, I want you to either with hasNextInt, or with exception handling as demonstrated above, I want you to ask them for a number. Finally, third step, I don't know why I just didn't make this one big comment. I did, right? So I don't need all these slashes in front of it. That was dumb. Okay, so ask for a year. Use either hasNextInt or try-catch to make sure that the program doesn't crash if they enter invalid data. So in that case, that's kind of implying that the year is an int. That kind of implies that you don't need to use hasNextInt or exception handling for that one or that one. Right? Make this variable a double. Make this variable an int. Make this variable an int just because it's easier to crash an int than a double. And you can crash an int just by putting in a decimal point. Okay. With the examples here, hopefully this will be a pretty easy assignment. So I hope that makes sense. Please contact me if it doesn't.